All right, guys, welcome back. Today we're learning about latitude and longitude. Let's start out first with why we have it. Well, latitude and longitude is a system based on our rotation relative to observations that we see of our sun, the moon, the stars. And we know that latitude contains, of course, parallels. The lines do circle around the Earth parallel to each other. They're kind of like, flat across. That's how I remember it. Lat is flat. Some key points about latitude. They're drawn west to east, left to right, but they don't measure that way. They measure up and down. They measure north or south of the equator. So the equator is 0 degrees latitude, and anything north would be, a certain number of degrees N or north, and south would be south of that. Latitude only goes from 0 to 90, no higher than 90. 90 is the North Pole, and 90 is the South Pole. So you can't go above that or below that, or you're in space somewhere. And the circumference of each circle does change as you approach the poles. Think of the equator would be the biggest circle, and the North Pole would just be a dot, and everything in between would be different sizes, getting smaller as you approach the poles. So here's a picture showing latitude lines, and you'll see how latitude lines circle right around. There's the equator, everything's parallel, 20 south, 40 south, and so on and so forth. 20 north, 40 north, 60 north, 80 north, 90 north. And on the inside of the Earth, the cutaway section, you can see why. This angle right here is 20 degrees. So that makes this 20 north. This angle would be another 20 degrees. Makes that 40 north, and so on and so forth. The angle between the equator and the North Pole, I know it's a 3D picture, so it's hard to see, is a 90-degree angle there and over there. All right. Cool little fact here. This is nothing you really need to memorize, but it is nice to know that each degree of latitude is always equal to 111 kilometers distance. So if you go from the equator to 1 degrees north, it's 111 kilometers away. That's about 69 miles. So you can calculate your distance from the equator just by knowing what degree latitude you're at. We're at 43 degrees north in Fort Plain. So if you want to find how far away we are from the equator directly north, you just take 43 and you'd multiply it by 111 kilometers. And that will give you how many kilometers we are north of the equator. I'm not going to do the math, but you get the idea. Okay, next, we're on to the meridians of longitude. You notice they're not called parallels. That's because they're not parallel. These are imaginary half circles. They're not real. Obviously, none of these lines are real. That would be silly, just seeing these lines from above, looking down on Earth. And they'd constantly need to be repainted all the time. And so let's just not go there. But these are imaginary half circles that are drawn from the north to the south poles. They don't go all the way around the Earth. Some key points. They're drawn north to south, but they don't measure north-south. They always measure opposite of the way they're drawn. So these measure degrees east or west of the prime meridian, which goes through Greenwich, England. Longitude goes up to a larger range, 0 at the prime meridian to 180 degrees, which is halfway around the Earth from the prime meridian at the international dateline. And longitude lines are not full circles. They only go from the north to the south pole and they stop. They are half circles and they're all the same length. So here's a cutaway section of the Earth. You can see lines of longitude start at the North Pole and they run all the way down to the South Pole. Now that right there is 15 degrees to the left of the prime meridian. To the left is west. So that's 15 degrees west, 30 west, 45 west, and going the other direction to the right of the prime meridian would be 30 degrees east, 60 degrees east, 90 degrees east, 120 degrees east, all the way around to the international dateline at 180 degrees. Now that's a side view, kind of a side view. If you look at a top-down view of the North Pole, you can actually see the prime meridian here going through Greenwich, England, which is right there, right in the backyard of the King of England. The Royal Observatory is where the prime meridian goes right through, because the King decided that's where I wanted it. The North Pole is right in the middle, and you can see as you go to the right in this case, or to the east, it builds 20, 40, 60, 80, 100, 120, 140, 160, all the way to the international date line. And then, if you keep going, it starts going back down because you're heading back to the prime meridian from the other direction. So all these numbers are west of the prime meridian. So remember, longitude only goes up to 180, doesn't go up to 360, because the prime meridian's that backside limiting point. So we are in the western hemisphere in North America and South America, and over here in Asia, they are in the eastern hemisphere. Parts of Europe are in the western hemisphere too, like these parts right here. By the way, before I move off this slide, you'll notice that the Earth's longitude lines here kind of make like hands on a clock. We'll get to that later, but you can actually kind of use this as a clock because the Earth is rotating counterclockwise in this picture. All right, let's move on. Important, the standard worldwide is to write latitude first, followed by longitude second. So you always write down, for instance, in foreplane, we are at 43 degrees north latitude, comma, and about 74 degrees and a little bit more, maybe 30 minutes or so, west longitude. And we'll get to the minutes and what all that is in another lesson, but you get the idea that latitude comes first, comma, longitude comes second. That's the format. If you don't do it that way, you're not going to get it marked correctly, so remember it. All right, let's practice the latitude and longitude at this point. Remember, it's latitude first, longitude second. So the latitude of this line, right here, that goes through that point, would be 47 degrees. So we write 47 degrees, and if you look at the number system, the numbers are going from 45 to 46 to 47. You have to ask yourself, where on Earth would this happen? Would it happen below the equator or above the equator? Well, they're increasing going downwards, which is south. So this is not a north latitude, this is a south latitude. It's below the equator. All right, let's try longitude. There's our longitude line. Obviously, it's 15 degrees, so we write 15 degrees. And if you look at the number system up here, 13, 14, 15, 16, 17, the numbers are increasing to the right. To the right is east. So this is 15 degrees east. Don't forget, if you're not sure about your north, south, east, and west, you got to compass rows, north, south, and then it spells we, west and east. So that's how you can help yourself remember if you're not good at that. We're going to be practicing a lot of latitude and longitude over the next few days. We'll get real specific coming up soon. All right, let's practice some on the board. You guys get your whiteboards out now.